Our last totally random topic of the day before we move on to the main narrative will be immutability. So what is immutability? It's a concept that we apply to specific types. And we'll say that a type is immutable if, when you instantiate something of that type, it can never change, no matter what. So as an example of some mutable things, let's say an array deck. So an array deck, when you make one, it is certainly mutable. You can add first, add last, and so forth. Planets, likewise, are mutable. Their velocity can change, their positions can change. But there are also other classes which are fully immutable. So for example, integers are immutable. Once you create an integer, once you wrap an integer in it, that integer inside that wrapper can never change. As maybe a more specific example that's not too simple, let's think about the date class. So it's just a class I threw together. It has 3 int fields that are all declared as public final. It has a private boolean that's called contrived, since this is a very contrived class, and it has a constructor. So once you make a date, there's nothing you can do to ever change any aspect of it. So if we look at this date class, all of these variables are declared final. And as a reminder, that means you cannot reset them. So even though they're public, an outsider who says new date cannot say mydate.month equals 5 or something. It will not work. The compiler will yell. Likewise, contrived, even though it is not final, there's no code inside the date class that ever changes contrived, and an outsider obviously cannot access or change it. So in this case, date is a totally immutable object. There's no way that this date object will ever do anything different. Another example is strings in Java. So it turns out in Java that when you create a string, it will never change. So for example, suppose you have a string and you want to change one letter in the middle, you actually cannot do that in Java. That's just not how strings work. And we'll talk a little more about that in the next slide. So the final keyword is a handy idea. What it does for you is it makes the compiler enforce the fact that something cannot change. But I will note that it is neither necessary nor sufficient to get immutability. All it means is that once you assign a value, you'll never change it ever again. But if you look at date, for example, if we just made all of these private, it would still be immutable, even without final. Okay? So basically the big picture with immutability is it means that the object, once it's created, there's no detectable way to change anything inside of it. So that could be handy, for example, in Project 2. You may have some classes that you decide, well, once I make one of these things, it can never change, and that just helps simplify your reasoning. So as far as the advantages of this goes, that's the main thing. It avoids certain types of bugs, it makes debugging easier, it constrains the set of things you need to worry about. So for example, like this mug, right? I'm not worried that it's going to suddenly turn into lava. It's just not on the list of things to do. So I don't have to hold this mug with a pair of gloves in order to use it. And likewise with a string, whenever you give a string to a function, it can do whatever it wants. And you know that once that function finishes running, that your string is exactly how it was, because you know strings are immutable. They cannot be touched. They're perfect and beautiful. So the other maybe analogy I use to take the string example even further is strings have a bunch of methods, right? They have char at, compare to, concat, split. So concatenate means concatenate with another string. Split means to split it into a bunch of pieces separated by this. It doesn't really matter. But the point is that even if you use all of these fancy features of string, it doesn't affect the string itself. And you know that, right? It has all these buttons you can press. And sometimes there's even instance variables you can look at, like windows you can look inside of. But it doesn't matter. In a class, which we call immutable, there's no change inside the object that could ever be detected. Okay. Now the downside of immutability is that if you want to actually change something, you can't. So if I have the entire text of Moby Dick, and maybe I find that Queequeg's name is slightly misspelled somewhere in the middle, I need to add like an E in there, you can't. What you have to do is make an entire copy of Moby Dick again, but now with the missing E. And that can cause performance issues. So it's a bit of a trade-off, but I'd say that immutability is a wonderful idea that you should take advantage of in Project 2. Maybe think about some classes as immutable. Now, one little tiny warning, just because you declare that a reference is final does not make the object referred to by that reference immutable. So if I say public final array deck string D equals new array deck, this creates an array deck and we hold its address in D, but all that final does is it means we can't take D and point it at a different array deck. The actual array deck itself can change. So if you call add last or add first or whatever, it will actually work. The thing that you can't do is on the next line say D equals some other array deck. Okay, So minor point there, but something that sometimes confuses people who are new to this idea.